Okay, hi guys. I'm quickly gonna work through this algorithm, longest path. So before I begin, there's an important label that you guys should all try and remember. It's this. Just get a nice little color here. This one. It's L of your VI. Okay, so I'm just gonna make this one bigger. Of your alpha, which is your weight of the path to that vertex, VI, and the previous vertex, I'm just going to say pred because it stands for predecessor vertex of VI, so the vertex that came before VI. This is essentially what we're going to be filling in here. So let's just start. So we are at this point. This is our source. This is the vertex we actually created. If they give you a graph and you see there's like numbers and stuff, then you need to add a source. So add a source, call it VP, and then add to all the other starting vertices that they gave you, draw edges to them and give them a label of naught. Okay, so because it's our starting vertex, it's gonna write in green. Close here. Okay, I don't think this is gonna work too well, so let me try this. Let's make it smaller. Yep, that's too small. Let's try 24. Good to go. Okay, that's good. Okay, so because we're starting here, remember this. So this, how much does it cost us to get to the starting point? Nothing. And what was the previous vertex? Well, there was none because this is our source. So if you have this, what you're going to have to do is, as you can see, there's nothing else on our table because there's nothing else we can choose. So because this is our only option, I'm going to draw a block around it. And because I've chosen this as my permanent label, we now need to label it. So yeah, we can just say this equals the L of VP. Cool. Now we have a permanent label. Now in this row, we're going to have to add these three options. And from that, we want to pick the longest path to them, or the highest value. So let me just get this out. Yeah, so we got the first one. It's going to be the black. First one's going to be naught because to get to V1, it costs naught. And the previous vertex was V1, or sorry, VP. Okay. It's the same here. 0. Because to get to V2, it costs nothing. And previous vertex was VP. And the same for the third one. Cost nothing to get there. And the previous vertex, where it came from, was VP. Okay, cool. So now what we want to do is we want to pick the highest value here. But they're all the same. So it doesn't matter which one we pick. So just pick the first one that occurs. We're going to pick that one. Cool. And now we need to label it. from the label is V1, and it came from VP. So as you can see now, we basically wrote down the first one, L of V1. If I want to write it out, it's going to be the alpha was 0 and the predecessor was VP. So now because we are here, cross this one out, basically cross this one out. So now we've got two options here. We can go here, we can go here. So in the next row, everything we didn't pick needs to go down one. So what I'm just going to do here, I'm going to just select this because I'm lazy, copy, cool, and we need to add the two new ones. So to get from V1 to V5, or sorry, to get from V1 to V4, it's going to cost us 5. Because to get from VP to V1, it was 0, and now it's 5. So it's 0 plus 5 equals 5. That's why I'm writing 5 there. And its predecessor was V1. That's exactly the same. There we go. So now the longest path algorithm says you have to pick the highest in this row. You have to pick the highest alpha. So in this case, it's going to be between, these ones are lower than the 5s. 5s are the same, so we're just going to go with the first one that occurs. Okay, that's cool. We're going to block that off. We're going to now label this as the L V4. So now this has a permanent label. So now everything we didn't use needs to go down one. So like this one, goes down one here into this new column. And let me just take a nice one there. These two come down as well. And now, like we did with the previous one, we got here. But notice how this line going to V6, there's another line going to V6 coming from V2. You see, we could go to V5 and V4 because everything going, all the predecessing vertices had been explored going to this one because there was only one. So we had gone there, so we know that, okay, this is the only longest path from V1 to V4. There's no other options. So because of this, we cannot put this now in this line. So here by V6, this one, we cannot put this value. So we're going to have to add these two because it's 0 plus 5 plus 6 is 11. So from V4 to V6, it's actually 11 because to get to V4 it was 5. Now to get a V6 it's 11, and if we want to get a V8, and let's say this was our only path, it would be 7 plus 11, which is 18, and then plus 6, so on and so forth. And for this one, for example, if we went down here to V8, it would be 5 plus 12, which is 17, to get to V8 from V5. But look here, this is the same scenario. If we go down here, now V6 hasn't been explored and V7 hasn't been explored. So therefore we can't say that we can actually go towards V8 if we get to V5. So what we're going to do now is we can't fill, let me just go here. So we can't actually fill this one in because we need this one first. So what's our options? Well, what I want you guys to do is when you see that you're waiting on another one, put in, and just put it in like pencil. Put in the label, because when we come to this, we're actually going to put in another label. So I'll show you guys when we get there, but let me just do this quick. So I'm putting it up here. I'm putting it up here because if we actually explored V2 now and V2 was bigger, V2 would go down here. So I'm leaving just place for in the event that we can actually start writing V6 as a permanent label and not temporary labels, then I have place to do it. Okay, well, let's continue. So these are 3 options. That's the biggest one. Do this, and this is going to be, now we've got a permanent label for V5. Okay, so what does V5 create? It creates, cross this one off here, creates this line, but we're missing 2 other edges. So we cannot add this to our next step. So these 2 come down, so we didn't use them. And remember what I said, when we write a nice light color, we just want to keep place. So where is it? V8. What will it be? Well, it's 5 plus 12, which is 17, and the predecessor for this one is V5. Okay, cool. So now these are only 2 options, so we're going to have to use the previous method where we just take the first one that occurs and then we permanent label. So now we can cross this one off, and look here. So now both the predecessing vertices going to V6 have now been explored. So now we can weigh them up. So what I'm going to do is here, where I blocked it, I'm going to draw. So now you guys will be able to see why I do it where the block is. I'm going to write 10 because it costs 10 to get from VP to V2 to V6. And this is from V2. So now this one obviously carries down because we didn't use it. And now this one has been sort of like activated, if you want to call it that. And we got options. So which one is the longest path to V6? Well, it's this one. It's this V11. So here we're going to, from our 2 options, we're going to just write the biggest one, and I want it in black. It's 11, and that predecessor came from V4. So now, with this being explored, we have something here in V6, but we haven't chosen it. See, as I choose them, I'm crossing them out. So you need a cross in order to explore. So V6 is the highest one. So we're going to pick it over here in this row, because our method says that we must, for the longest path, we must always pick the highest possible value. This is V6. Now I can cross it off here, and I've got two kind of like outstanding lines, but I can't write down the value of V8 just yet because I still need this V7 to have a cross by it. Okay, so let's just take all that off. So now my only real option for the next one is going to be this V3. So I'm going to block it, which means I'm picking it, and I'm going to write that it has been chosen. So what you can think of this is as, what you can think of this as is you're adding it to sort of like your end graph of permanent labels. So you got like a, this is, sorry, it looks like something weird. So you got this set where, and in this set so far it's all the blue. This is a permanent label graph. So it has all the V's with the permanent labels. So you got VP, you got V1, got V4, got V5, got V6, got V2, and you got V3. And that is all things we have in the sample graph. So this is why we kind of having, and obviously this is at this point, and then obviously all the things that are not in will make up the graph with the non-permanent labels. So these are temporary labels because they haven't got labels yet. And whenever we write an L with them, then we take this out of it and we add it in here. So this is the next step. Okay, so this is what I just did there is what I'm about to do next. So V7 and V9 are two options. Let me just put them in here. So here they go, V7. Oh, we want that in black. V7, how much does it cost to V7? Well, to V3 it was 0. So now from V3 to V7 it's 8. So it's 8. Where did it come from? It came from V3. Cool. Now that's exactly the same. Exactly the same as V9. It's also 8. I'm just going to put it in there. So they're the same. So you just got to pick the one where it's going to be first. There we go. And let's see, what does that open up? So we pick V7. And And now we have all of these options. So, oh sorry, I put this one in the wrong place. Forgive me. So, that V6, I did not add the temporary label for V6. So what was it? It was 10 plus 7. It's 17. Sorry, I was thinking about that. It's 18. Because it's 11 plus 7, 18. Sorry guys, that was a huge mistake from my part. This one here is 17. Okay, cool. So that came from where? V6. And now down here, we got that last option, it's 8, that's 12. We got the 12, and that came from V7. Cool. So now that that one has a permanent label, now that V7 has a permanent label, we can write the highest value here. So we're looking at this one, and this one. So obviously, this one over here is the highest value. So that's the one I'm going to fill in over here. So we're going to want the black. Going to want to write it in. Sorry if I'm going quite slow here, guys, but I just want to make sure I get it right. And the previous vertex came from was V6. Cool. Okay, so now this is our only option. Sorry, no, it's not our only option. This one we didn't use, so this one comes down. Yeah, I'm pretty sure I already, yeah, there it is. There we go. So we got between these two, and we're going to pick the highest one. So let's pick the 18 because it's the highest one. Let's label it quickly. Of V8. Cool. And we didn't use the previous one, so we're going to bring it down. And here we're going to do the same thing as these temporary labels, because for V10, yes, we've crossed off. Yes, we've crossed off V8, but we haven't crossed off V9, so we can't pick this end vertex just yet. So let's just write here what it would have equaled. So it's 18 plus 6, 24, and it came from V8. Cool. So now our only option is the V9. So let's quickly select it. Cool. And we're going to write it in there, saying it has been selected. And here we go. Now we're going to add this in here. What does it equal? It's 8 plus 10. Okay. That's 8 plus 10, that's 18. and it came from V9. And of the highest ones here, we're going to put in this option here, because now all of the nodes have gone there. So black, right out, it's 24 was the highest one. And then it came from V8. Okay, so cool. Now we've got everything. Now there's only one left. And we got all the longest paths. V10. So this is what you're going to have to do once you got this. So once you've got all of these blue blocks and you've ticked them all, and here completed all the correct paths to get your longest path. I'm actually going to write that one in red. So now this is the highest number. So this is the critical path. So the critical path is the highest path, is the longest path, sorry, the longest path in graph. That's the critical path. And in this instance, we can see it's V10. So we can write a whole of V10, and it equals 24. So here you can actually say this equals 24, and the path equals, so what I do is I go V10, and now it gets easy, and then I just look at the predecessor. So V10 went to V8, so make a mark there, V8. V8 went to V6, came from V6, sorry, not went to, so came from V6. V6 came from V4. And V4 came from V1, and V1 came from VP. Okay, because VP was our source. So now you've got both the path and the weight. Thanks guys, I hope this helps you. If they ask for the critical path, they want this one. Obviously, all of these other ones, so everything that wasn't the critical, a part of the critical path, these ones are also your longest paths, even though if you were to go to that number. So if you want to know what's the longest path to get to V5, it's actually 5. Okay. If you want to know the longest path to get V7, it's 8. If you want to know the longest path to get to 9, it's also 8. Longest path to V8, it's 18. So on and so forth. Okay, so the theorem Theorem 3.7 this theorem, it's exactly the same as, okay, let me just open up my documents here. It's exactly the same Okay, so you can see this is the end graph, and we got that. Theorem 3.7 is exactly the same as this in and out, input and output. It's the same, and these 4 steps here, it's exactly what I said. So whenever you're adding a vertex to your S, you're removing it from the knot in S. Therefore, you're making your longest path and to that vertex. And here's the same. So, okay, I hope that helped you guys. I'm just going to leave it there. So, yeah, till next time.